So for part 2 of the Sprite tutorial, I've set up some characters complete with animations and a level that we're going to be able to explore. And this will help greatly in explaining a lot of the concepts that we're going to be doing, and it also looks a lot nicer than the ugly sprite that I had drawn for the first tutorial. So with that in mind, we're going to continue on. Alright, I've got 2 sprites now instead of just one. One is the player sprite, and he is the skeleton. And what I did was I changed the parameters of the sprite first of all. So he's now referenced to 11 and 4 on the board, which is this spot right here. And instead of being 4 tall and 4 wide, he's 2 wide and 3 tall. So I'm using these characters here. And so the width is 2, the height is 3, the collision X is 0, and the Y is 2. And the collision width is 2, and the height is 1. So he's only tangible down here at his feet, and the upper part of his body is intangible. So basically, this game is looking down at the player at a kind of a 3/4 view from up in the air, so his body doesn't collide with anything. So I took the bits of the program that I had written in the first tutorial series that dealt with controlling a sprite through button commands, and I added some programming that added animation to the sprite as well. So everything else about this program is pretty much as it was at the end of part 1 of the Sprite tutorial. So now we're going to start adding some more commands. So the first new command I want to show you will allow you to have the screen position follow the sprite around when he moves. And to do that, you use the command set sprite and then your sprite number or the counter representing that. And then the rest of it is called a set view, and so it's sprite number set view to 1. And every time you issue this command, it will center the screen over the sprite that you have numbered here in this part. So it will move the screen 1 time, so you need to run this command in a loop. And if you do that, then as the sprite moves around, the screen will pan around with him and follow him wherever he goes. If you only use this command once, it will only move the screen 1 time. So I'll show you how this looks. Okay, so now I have the a slight delay. I think I want to move this command to before the cycle 1, so I won't have that slight delay in the movement. Let's try that again. Yep, okay, now it follows him smoothly. So the player sprite will always stay in the center of the screen unless you go to the edge of the screen, and then the screen will stop panning and the sprite will continue. But otherwise, he's going to stay in the middle of your screen. So when working with sprites, you're going to probably find that it becomes necessary to cordon off a part of the screen that is not part of the normal playing field. For this tutorial, I chose the top of the screen. So I've got my 2 sprites. Their reference points are set up here. And if I had a game that was largely using sprites, I would want to have obviously a lot more sprites populated on this board, and I would probably want to have their reference points up here as well. So it would be very handy to have a part of the board just cordoned off that you didn't actually play on. And so for that purpose, in this tutorial, I've drawn a custom block border around the playing board so that the player can't actually leave that area. Now, you're probably going to want to do some sort of program that's going to allow your player to walk to the edge of the board or the edge of the playing screen without actually seeing what's behind the curtain. In other words, what's up here and what's to the side. One way to do that, one simple way to do that would be if you set up some counters that track where the player is on screen and have them delivered to the bottom. You can see the player's X and Y coordinates, and you would just very simply write down those numbers of where the edge of the playing screen is. The point, in other words, the point that you don't want the player to walk past. And you could just very simply change out the custom floor that the player is walking on for a custom block when you reach the edge, and then you could just have an invisible wall that the player couldn't walk past that would allow you to not have to do any complicated programming. Your player just simply wouldn't be able to walk up to the edge of the board like this. The screen would just stop scrolling because the player simply couldn't walk any further. But if you wanted to actually use some programming to prevent the player from walking to the edge of the board, I will show you that too. Okay, the simplest way to set up a condition where the game won't scroll past the edge of the level that you've designed for your player is with an expression. And here I have just a single long expression that sets up basically a boundary box for the player, and if the player steps foot outside that boundary box, then it simply skips updating the screen position and jumps to a label afterwards called skip view. So this is a if. So this tests for a condition, and basically the condition is if sprite player X is less than 41 or X is greater than 161, or sprite player Y is less than 23 or greater than 48, then it will go to the skip view label. And that works like so. Yeah, it's not a perfect expression. It works fine enough when you're going outside of the boundary in only one direction at a time. For instance, if you're just going up or you're just going east, it works fine. But when you're going to two directions, up and east, then it starts to jump when it gets back into view. Because remember that the screen is not updating its position until it gets back inside that boundary box. So you could step outside the boundary box up here, walk over here, come down, step back inside the boundary box, and then it will update. So that's a little jumpy. Now that simple expression can have its uses. For instance, in a side-scrolling game where you're typically just going left and right and you're not going north and south too much, or you're not going up and down too much, then that might not be an issue and that expression might work okay. But maybe you need something a little bit more complicated for a game such as this. I'll show you how to do that now too. Okay, so the first thing you'll need to do is figure out what you need to do to place your character in the center of the screen. So you're going to need to know how many blocks or spaces it is from the edge of the screen to the edge of your player sprite. So in this case it is 39x and 11y, and I figured that out by just drawing a box like this, just pressing V to go to view, putting the player in the center of the screen, and I actually counted over using just Alt and the arrow keys. I just went 10, 20, 30, 40, and and then from this side 10, 20, 30, 40, and then from the top 10 and 10. So when I counted it out, it actually comes to, from here starting at 0, this is 39, and from here starting at 0 and counting down, this is 11. So I need to remember those numbers or write them down, 39 and 11. And the next thing you'll need to do is you'll need to create a robot in the bottom rightmost edge of your screen. And the reason for this is that this is the last spot that gets updated on the board. MegaZeux scans the board every cycle from top left to bottom right and goes through every program of every robot on the board. And the reason you want your scrolling robot at the bottom rightmost corner is that you want it to be the last thing that updates. You want your screen to be moved after everything else has been done. So create your robot, and you're going to need to set up some counters. You could use local counters, but if you want the counters to be able to be accessed by any other robots in the game, you're going to want to set aside some special counters. And you'll need to punch in the numbers that you began with, the numbers that you figured out, how many spaces X and Y the player is from the edge of the screen. Alright, next we have a main loop, and this loop is just checking for whether the player is inside of a certain boundary or not. And so what I set up was if the player's X position goes less than 42 or greater than the board width minus 44, or less than 24 or greater than 47 Y, then it goes to one of these subroutines. So down here I set up an example. So go ahead and ignore this commented line for a moment because it's just part of the example here. So if the player X goes less than 42, it's going to jump down here to the subroutine left edge. It's going to use an expression to set screen position X. So the expression is going to be sprite player X minus 41, and then add the counter center X to that. So for this example, let's say that the player has gone to X position 40 on the board. So that's 2 less than the boundary here. So it's going to jump down to the subroutine, and so it's going to subtract 41 from 40, and it's going to leave you with -1. And then it's going to add -1 to 39, so screen position is going to equal 38. So when it's done with the subroutine, it will jump out of it and go back to return, so it'll come back up here and continue the rest of this program. And then when it gets down here, it's going to scroll view position, and it's going to take player X and subtract screen position X from that. So the player's position on the board is 40X, and it's going to subtract 38 from that. And this, of course, will set the scroll view X position to 2, which if we go out here to the board, that would mean that the left edge of the board would be right here at our border, and it wouldn't go past this point. So if we go ahead and test this program, you can see that it works as intended. So that program looks like it works.